In this video we're going to talk about polynomial division, the two types of division. The first type is long division, the second type is synthetic division. Synthetic division is a shortcut to polynomial division, and you'll see that in the later half of this video. The first type though, long division. Long division works the exact same way as division worked when you were a kid. You had a problem like, say, 342, and you were asked to divide it by, let's say, 7. And then this right here, 342, would be called the dividend. 7 would be the divisor, and whatever it would equal would be the quotient. Okay? And what you would do if you were to do this problem here is you would set up a 7, have a parentheses, say 342, put a bar over top. 7 doesn't go into 3, 7 goes into 34 as a whole 4 times. 7 times 4 is 28. 34 minus 28 is 6. Drop the 2, you get 62. 7 goes into 62 8 times, and that 7 times 8 is going to be 56. 62 minus 56 is 6. And this right here, the 6, is your remainder. Alright, so your answer would be 48 with a remainder of 6. Okay? Long division of polynomials works the same way, or division of polynomials works the exact same way. Alright, so in an example here, we have 6x cubed minus 25x squared plus 18x plus 9. We're dividing this entire polynomial here, this entire third degree polynomial, by x minus 3. Okay, here's our dividend. Here is our divisor. So the way we would set this up, our divisor comes on the outside, x minus 3, open up the parenthesis there, and then write your dividend under the division bar there. So we have 6x cubed minus 25x squared plus 18x plus 9. And move that over a little bit. And now the question we must ask ourselves, what do we multiply x by to get 6x cubed? Well, if we multiply x by 6x squared, right, is 6x squared times x is 6x cubed. That gives us our 6x cubed. Now, because we're using 6x squared, we don't put it on top of the 6x cubed part. We put it on top of the corresponding x squared column. So our 6x squared is going to go right there. And what we're going to do is multiply x minus 3 by 6x squared. So 6x squared times x is 6x cubed. 6x squared times negative 3 is negative 18x squared. We're going to subtract this expression here from our original. What we'll notice is 6x cubed minus 6x cubed go away. And then we're left with negative 25x squared minus a negative 18x squared. Double negative makes a positive, so this is really negative 25x squared plus 18x squared, which leaves us with negative 7x squared. Like what you did before, we need to drop a term. So bring down that plus 18x. And now we ask ourselves, what do we multiply x by to get negative 7x squared. Well, if we multiply x by negative 7x, we will get negative 7x squared. So we'll go 6x squared minus 7x. So negative 7x times x is negative 7x squared. And then negative 7x times negative 3 is going to be a positive 21x. Subtract this expression from this one. Negative 7x squared minus a negative 7x, they go away. And 18x minus 21x is negative 3x. And now we bring down the 9. Now you continue that pattern. What do we multiply x by to get negative 3x? Well, we multiply it by negative 3. So negative 3 times x is going to be negative 3x. Negative 3 times negative 3 is a positive 9. And when we subtract each of these terms, they're going to go away, and you're left with a remainder of 0. So when we divide 6x cubed minus 25x squared plus 18x plus 9 by x minus 3, we're going to get this answer right here. 6x squared minus 7x minus 3. And we could check this by multiplying these two terms together, 6x squared minus 7x minus 3 and x minus 3. We could do that if we want to. Okay? So that's long division without a remainder, with no remainder. Let's do another one where there is a remainder. And maybe a little other funky things. Okay? So let's say we have the example of divide 3x cubed minus 2x minus 4 by x plus 1. Okay? First thing that I notice in this example here, our degrees go from 3 to 1. There is no second degree term here. So what we're going to have to do is we're going to have to rewrite this as 3x cubed plus 0x squared minus 2x minus 4. Alright, we need this 0x squared to act as a placeholder. So if you don't see a term there, like an x squared term, say this was minus 2x squared minus 4, we'd have a 0x term here. But since we don't have a second degree term, we have to have a placeholder for it. Alright? And then we could set up the division appropriately. X plus 1 is your divisor. Your dividend is now 3x cubed plus 0x squared minus 2x minus 4. Put your bar over top. Now, same process as before. What times x gives you 3x cubed? Well, 3x squared times x gives you 3x cubed. So when we multiply x plus 1 by 3x squared, we get 3x cubed plus 3x squared. Notice if we didn't have a placeholder, we would have a x term and an x squared term over top of each other. That's not appropriate. We don't want that to happen. We want x squared over x squared. So now when we subtract these terms from each other, right, the 3x cubes go away, and 0 minus 3x squared is negative 3x squared. Bring down the minus 2x, and keep asking yourselves the same questions. Well, negative 3x times x gives you negative 3x squared. So we have 3x squared minus 3x. 3x times x gives you negative 3x squared. Negative 3x times 1 is going to be a negative 3x. And subtract. These 3x squareds go away. Negative 2x minus a negative 3x squared minus a negative makes a positive. So we're left with 1x. Bring down to 4. And x, what times x gives you x? Well, x times 1 gives you x, so we'll add 1 here. And then we're left with x plus 1. Oh, this is going to be a minus 4, I forgot the sign. And then subtract. These x's go away. Negative 4 minus 1 is a negative 5. So this time we have a remainder of a negative 5. And the way we write these remainders is as such. Instead of putting r with a minus with the negative 5 there for the remainder, we're going to add the remainder, which is negative 5, over the divisor, x plus 1, which is x plus 1. That's our remainder term. Alright? So always, if you come up with a remainder here, you're going to create a fraction. The remainder goes in the numerator, and the divisor goes into the denominator here. Because we have plus and negative here, we could also take that negative and slap it out front here, like that. But I'm perfectly fine if you have plus a minus there. That's perfectly fine, or should be accepted. Right. Now, we did 2 examples with long division. Let's do one with synthetic division now. Synthetic division is the shortcut of the 2. Alright, and I'm going to do the same exact example here, except I'm going to do it with synthetic division. Okay. So now, instead of doing long division, we'll do synthetic. And synthetic division is going to be probably your go-to tool for most problems in pre-calc or even in calculus. Right? So what we do in synthetic division here is we start by having a little box right there, like that. Nice little box. Right? The term that goes inside here is the opposite of the numerical term that is in the divisor. So we have x plus 1. This term here is going to be the opposite of positive 1, which is negative 1. We still need a placeholder here, so we're going to keep that going. And then we write the coefficients of every term here. The coefficient of x cubed is 3. Coefficient of x squared is 0. Coefficient of x is negative 2. And we have negative 4 as a constant. Leave some space between them, because we're going to be doing some calculations here. And then give yourself some room, because you're going to be writing some stuff underneath each of these terms here. Draw a line. And then underneath this last term here, this negative 4, I'm going to put a little line right here, because what's going to happen is, whatever this term is here, that is your remainder. That's your remainder. Alright, so the first step after you complete all this stuff is we're going to bring this 3 down. And then we're going to take this 3 and multiply it by negative 1. 1 times negative, or 3 times negative 1 is negative 3, and we write it up there. add them. 0 plus negative 3 is negative 3. Negative 1 times negative 3 is going to be a positive 3. Negative 2 plus 3 is 1. Negative 1 times 1 is negative 1. Negative 4 plus negative 1 is negative 5. Now, what we have to do here, notice we don't have coefficients at all here yet. We don't have a full quotient yet. Our original dividend was third degree. So these terms here are going to have x terms that are 1 degree less than the dividend. So when we put our x terms in here, this 3 is going to be x to the power 1 less than that of the dividend. So 3 minus 1 is 2. Negative 3 is going to be negative 3x. We don't have anything there. So our answer here now is going to be 3x squared minus 3x plus 1 plus our remainder, which is negative 5 over x plus 1. And this right here, make sure I tell you the right thing here. Alright, so this is our answer right here. Alright, so that's the basics of division of polynomials. Hopefully you guys got something out of this lesson. Again, synthetic division is probably going to be a very close friend to you as you continue into your pre-calc and calculus courseworks. So, thank you.